Hey Cameron, guess what?
What's up?
We finally did it. We went solar.
Nice, awesome.
Take a wild guess. What was the first question my daughter asked me?
I don't know, but
Are we going to have power when the grid goes out?
of course,
Right?
right? Always. Well, the good news is with StorEdge, now you can say yes.
If you have a solar system, you might notice that the energy increases in the morning, peaks around noon, and then decreases as the sun sets. However, if you compare this to your energy usage profile, most people use a little bit more energy in the morning and then see their energy usage spike at nighttime. The utilities know this, and so what they're trying to do is to create rate structures that lower the value of energy early in the morning and in the afternoons when you're producing solar, but then spike the value of energy in the late afternoons when you're buying energy from them. A battery enables you to take control of this situation. You'll store the energy at noon when you're producing the most and demanding the least, and then you'll have that energy to pull from your battery in the afternoon instead of paying those high utility rates. All right, so tell me about the system.
Yeah, this system's a little bit different where it connects a PV array and a battery to the StorEdge inverter.
Nice, but it looks like it's just a 7600, but obviously there's something special.
Inside here, we're going to see the battery connection unit, which enables us to talk to the battery. The part number is unique as well.
Let's take a closer look at the inverter. Under the inverter and above the StorEdge connection unit, you can see an LCD button, a red toggle on-off switch, along with two communication glands. The on-off switch is different than the safety switch, so pay attention to which one you need to use. You can see one DC input port on the left and one DC input port on the bottom.
One AC port on the bottom and one AC port on the side.
On the bottom of the battery connection unit, there are two additional drill templates in case you need to add more conduit. Once the plastic covers have been removed, we can see the inner workings of the StorEdge connection unit.
Inside, you'll find the DC battery connection, PV string positive and PV string negative. Notice how there's room for two strings. Here we have a thermal power to a battery. This is our control to the battery. Here's our control to the smart meter. You can see this is the connection for the Autotransformer's thermal sensors. Here's our AC connection to the backup loads, our AC output to the grid, and our AC connection to the Autotransformer. You'll have to install the supplied 9-volt battery here. Double check that the battery fuses are rated for 25 amps. This is the load bypass switch. The bypass switch should be in the 1 position. 0 is off, and 2 bypasses the inverter. This breaker protects the backup load center. This is the DC safety switch. The PV connections are made on the lower terminal blocks. Both positive connections are grouped on the left, and both negative connections are grouped on the right. Now to install the battery. First, mount the battery to the wall. Be sure to follow the manufacturer's instructions carefully. Also, make sure that you leave enough space around the device to allow for proper airflow. LG recommends 12 inches on either side. Once the battery has been successfully installed on the wall, we're going to open up the cover and get ready for wiring. To open the cover, you will need to press the release button and then unlatch the clip on the back. Remove the plastic cover to access the wiring compartment by removing this screw. It's always a good idea to make sure that the circuit breaker and the auxiliary on-off switch are both in the off position before we start wiring. You will need to run 10-gauge wires in red, black, and green, and then an additional communications wire. I recommend something that is rated for 600 volts. For the control and communications wiring, use this RS485 port. SolarEdge can provide you with the quick wiring and configuration guide. In this guide, you will see that you're only going to use 4 ports. Now that we have the battery side wired up, we will replace the battery cover and then move on to the inverter. This is the battery connection for your DC positive and DC negative conductors. Push your flat blade screwdriver to release the compression clamp and then land your conductor here. Pull the screwdriver out, tug test, and you're done. You can see I have 3 dip switches instead of 2 dip switches. This means my conductors will land in the following order: green, blue-white, blue, orange. Once the DC positive and negative conductors are landed, we're going to land our communication and control wiring for the battery. To do that, you're going to take your flat blade screwdriver and press it here, landing your stripped conductors here. Connect the grounding cable using at least a 10 gauge wire.
Be sure to terminate all of your grounding conductors in the grounding bar.
The terminal block on the far left is for our backup load center. I'm going to make my connections by pushing my screwdriver here and landing my conductors here. Moving to the right, you can see the connections for my main service panel. This allows energy to be backfed to the grid. I'm going to land my conductors here, while again opening up the pressure clamp with my screwdriver here. Install the bracket with the flat side facing down. Verify that the bracket is firmly attached to the mounting surface. Hang the Autotransformer on the bracket. It is a solid product and a bit heavier than it looks, so make sure you have a good grip. Insert the 2 supplied screws through the outer heatsink fin on both sides of the Autotransformer and into the bracket. You will need at least an 8 gauge wire for the 3 AC connections, line 1, line 2, and neutral, and at least a 10 gauge wire for the equipment grounding conductor, as well as 2 24 gauge wires for the temperature sensor.
Connect your line 1, line 2, and neutral conductors into the Autotransformer.
For the thermal sensor, insert a flat blade screwdriver into the square opening here at the top of the terminal block. Insert your wire into the round opening and remove the screwdriver to clamp the conductor in place. When you have finished terminating all of your conductors, place the cover back onto the Autotransformer. Now I'm going to make my connections for the Autotransformer. The Autotransformer has 4 conductors, line 1, line 2, neutral, and ground, as well as a communication wiring for a thermal sensor. To connect the thermal sensor, I'm going to open up the clamp here and then put my conductor here. Now I'm going to wire line 1, line 2, neutral. Connect the supplied 9-volt battery right here.
Okay, looks like we have a backup loads panel going here.
Yeah, this is your backed up loads that is connected to the StorEdge inverter. We can see our line 1 and our line 2 wires coming from the inverter that we already wired. They are connected to this 25 amp main breaker. Now we recommend no more than 25 amps per phase, but let's take a look at what we're protecting. We're protecting a 20 amp circuit from the kitchen, so that's your refrigerator, and we're also protecting a 15 amp circuit from the home office. Now what that is it's your modem and router, so if the power goes out, you still have internet access.
So basically we have our kitchen, a refrigerator, general lighting, some router. We have a couple empty slots here.
Yeah, so we can add more things if you want to, but I recommend keeping it simple, do a few things, select some general loads that you want. We want to maximize the lifetime of the battery by minimizing the amount of energy that we're drawing from it.
Okay, nice. So this is sort of a smart load selector panel that you've built here.
Yeah, pretty much. So there's an automatic transfer switch built into the StorEdge inverter that when the grid goes out, it will automatically throw the switch and power these backed up loads.
Nice.
So there's nothing that the homeowner has to come out and do or switch over. It's all automatic.
Very nice. This is the SolarEdge electricity meter. It has the ability to measure the homeowner's consumption. It's extremely useful when connected to a battery because it allows you to do zero export mitigation, demand charge mitigation, and also manage your time of use. So it's a really helpful tool, very handy to use anytime you're doing a SolarEdge or StorEdge installation.
The SolarEdge electricity meter is enclosed in a NEMA 3R box. This means it is suitable for indoor or outdoor locations. You want to install the SolarEdge electricity meter next to the main service panel.
Use a unibit to open up your conduit entry port.
Remove the end stops off of the DIN rail to be able to take out the terminal blocks. Use the supplied bracket to mount the meter box. Make sure the semicircles are pointed downwards.
Using the 4 supplied screws, secure the meter enclosure to the mounting bracket. These are split core CTs which are used for monitoring current flow to and from your home.
Installing the CTs should be done by a qualified person only.
Locate the arrows on the CTs and make sure that they are pointing towards the grid.
close the split core CT and make sure that it won't open again. They should be located on the feeders to the service entrance. To power the meter, we're going to need a 15 amp 2-pole breaker that also doubles as our voltage sensor. Connect your grounding and neutral wires to the appropriate bus bar in the service entrance. Then connect your line 1 and line 2 conductors to your breaker and put your breaker in place. Terminate the black and white wires from the CTs here. Be sure to note line 1 CT goes to CT1 and line 2 CT goes to CT2. To connect the power supply to the smart meter, we're going to land our line 1, line 2, and neutral conductors on the green terminal block located on the right side of the smart meter. I also terminated my grounding conductor on the grounding bus bar below. Insert your RS485 wires in the B-, A+, and G ports. Return the terminal block back to the smart meter. Once the wiring has been completed, insert the DIN rail end stops again. Turn on the breaker to the smart meter. The CT lights should illuminate.
Your SolarEdge smart meter might look like this and have 8 dip switches. It is important to note that dip switch 2 and 7 should be in the up or on position, while all others should be in the down or off position.
Now that everything is complete, let's close the cover to the smart meter. We have already fed our RS485 wires from our smart meter into this conduit, and we need to connect it to the StorEdge inverter. The RS485 wiring from the smart meter can be connected here. This is a compression style terminal block. Release the clamp by pressing here, insert the conductor here, then remove the screwdriver and tug test, you're done. Once all of the wiring has been completed, we're going to reinstall our plastic cover using these 4 screws.
Before closing up the connection unit for good, we need to make sure that our breaker is in the on position and that our bypass switch is in the 1 position. Finally, we'll close up the battery connection unit.
Okay, now that the wiring is done, let's commission the system. The theme I want you to remember is activate, upgrade, pair. That's the process we are going to follow. Remove the inverter's cover by loosening all 6 screws.
Hey Cameron, how's it going?
Hey Mike, what's going on, man?
Looks like you've already got the communication card installed. That was fast.
Yeah, thank you. It was actually factory installed from SolarEdge, so we no longer have to put that card in. All you have to do is take this antenna off the bottom here and then just relocate it to the top.
Nice.
For step 1, we need to activate the inverter first. Verify that the serial number on the supplied activation card matches the serial number to the inverter. Insert the card into the slot located on the communication board. Make sure that the red toggle switch and the StorEdge connection unit DC disconnect are both in the off position. Turn on the photovoltaic breaker in the main service panel. Once the AC power is on, the inverter will automatically detect the activation card and start running the activation script. When it's finished, the screen will tell you done. Turn off your AC power to the inverter. Remove the activation card. Step 2, upgrade the firmware to the inverter and battery. Download the latest firmware version to your StorEdge inverter here. Insert your micro SD card with the latest firmware version on it.
Turn on the battery's auxiliary switch and breaker to ensure that the firmware upgrade occurs to the battery, as well as the DC disconnect switch.
Turn on the AC power again. Once the firmware upgrade is complete and successful, turn off the AC power and remove your micro SD card. This can be used at any job site with a StorEdge inverter.
Once everything is completed, it is time for step 3, pair.
Turn off the battery's breaker and then the auxiliary switch. Before we start pairing, we want to make sure that the inverter cover is on. Tighten all 6 Allen screws.
To start pairing, turn on the DC safety switch. You might notice a battery communication error. This is due to the battery being off. To initiate the pairing sequence, press and hold the green LCD button. The LCD screen will indicate when to turn on the red toggle switch. Do so now. Turn on the battery's auxiliary switch and breaker. Make sure the battery is charging and discharging before you leave the job site. Refer back to SolarEdge.com for more how-to videos.